Oil and minerals recovery using microorganisms. A microorganism or microbe is an organism which is too small to be seen by the unaided human eye. They are microscopic. The study of microorganisms is called microbiology. Microorganisms include bacteria, fungi, protists, and viruses. Meet the microbe eating the Gulf oil spill. Thalassolythus olivera, much like a Burkimensis, makes its living by turning the algae in oil into microbial cells, carbon dioxide, and water, and can be found from the Black Sea to the Gulf of Mexico, as can other members of the Thalassolythus genus. Unfortunately, such similarly minded bacteria don't cooperate. Some experiments show that adding Thalassolythus olivera reduces the activity of Burkimensis and other oil-eating microbes, as the tiny bacteria from oil-ingesting suprimary. Humans aren't the only species waging chemical warfare in the Gulf. Neptunomonas genus. Some members of this genus attack the carcinogenic constituents found in most oil deposits, the aforementioned polycyclic aromatic hydrocarbons, and can be found throughout the planet's oceans. Members of the genus play a role not only in cleaning up oil spills, but also the fatty acid residue of whale carcasses. Like Neptunomonas happonica features here, other microbial genuses that contribute to such toxic tie-dyeing are Pseudomonas and Fabio, although they may not be as abundant as Neptunomonas or Cycloclasticus. Olisfera genus, another alkane eater, like a Burkimensis, various Olisfera turn oil into more and more Olisfera cells, along with carbon dioxide and water. One unintended side effect can be local dead zones, as the industrious microbial consortia, like the pictures here, consume much of the dissolved oxygen in the seawater as they feast on the oil. Another extremophile species in this genus has been found in Antarctic waters, as well as the subtropical waters into which the Macondo whale has been spilling. Oceanoperiales. This order of microbes, part of the Phociobacteria phylum, named after the shape-shifting Greek god Phocius, assume a number of forms and rules in eliminating an oil spill. The most famous oil-eating member of the order is the aforementioned Burkimensis, but other members can play the role of eliminating petroleum as well. Pictured here is the salt-loving Halumonas elongata, which grows best in extreme environments but does not eat oil. Aurelia genus. This clan of oil-eating microbes can be found from cold Arctic and Antarctic waters to the balmy sea of the Gulf of Mexico. It also has the ability to thrive in the variety of habitats, from marine sediments to Arctic sea ice, making it one of the more adaptable spill fighters. Given that the oil in sediments or cold waters is much harder to break down, scientists are in hot pursuit of this wide-ranging exemplarized spill fighting race. Breeding for Cycloclasticus. Some of the most dangerous constituents of an oil spill are polycyclic aromatic hydrocarbons, volatile molecules that can be highly toxic. Fortunately, at least 23 strains of the bacterial genus Cycloclassicus native to the Gulf of Mexico can degrade such greasy oil constituents by tapping them for energy. Even better, some members of the rod-shaped group can eat other aromatic hydrocarbons that are even more toxic, such as solvent, and they have tiny flagella to help them move from source to source, cleaning up toxics as they go. As a result, scientists are busily decoding Cycloclassicus progeny, a stream found in the waters on the Puget Sound and being dragged for here, in hopes of improving its toxic Avengers ability. Alcanevorox borcamensis, a rod-shaped bacterium. Borcamensis has played a role in oil spill cleanups from Alaska to the Mediterranean waters near Spain. Also, it persists in low numbers at all times. The bacterium blooms after an oil spill and has the ability to both break down the alkalines that make up part of the oil as well as the spread of biodispersants that help other microbes feed on other constituents of the spill. As the result, scientists have been attempting to soak up this oil eater via genetic manipulation in order to make a spill-fighting supermicrobe. So far, they have not improved on evolution's design. Gulf of Mexico oil spill cleanup solution biofilter.
I know it's an accident, things happen, but it's still a stressful event. It's at our front yard. It's getting trashed right now.
Nobody ever thought it would get this far. It's just recently begun to wash ashore.
We've had oil on our beaches for about 2 days now. It's very disheartening to those that fish here, live here, and have survived Katrina.
This is the Mississippi Sound, almost directly in the center of the northern Gulf. Where we're standing here right now was ground zero for Katrina. So this is the second time in 5 years where we've had something of a magnitude that we've never seen before.
And it's been the most frustrating thing that we've ever gone through because we have been trying anything we can to try and stop this and be prepared for it, to no avail. So why are they continuing to use 30-year-old technology?
The booms which are already in use, they don't stop and they don't catch the oil.
The other day I witnessed some of this oil stuff lapping over the boom. You get a 1.5 to 2 foot chop, it either washes under it or over it.
And I personally began to realize that there were proven technologies that have been used in other places around the world that were not being considered.
This is bentonite clay. You can see that it's kind of gray, and these microbes feed on that crude oil. The biofilter that's coming from Russia is strands of material. So the microbes will live inside their biofilter, and then as the oil gets adhered to it, the microbes will destroy the oil.
I witnessed the biofilter next to a traditional boom. The biofilter remained in place. It was securely anchored. It moved with the waves and the tide, and the traditional boom was in a knot.
Oil will stick to the fibers, unlike the existing booms that the oil doesn't stick to. The microbes start to generate carbon dioxide as they destroy the oil.
It's a non-toxic viable solution to the problem, and it's not 30 years old. This product is one that I'm very impressed with.
You know, if anything ain't old, I say let's put them out there because it's the only they ever to eat.
The reason that people live on the Mississippi Gulf Coast is because of the connection to the water, and we utilize that water. This is our way of life. It is our life's blood.
Yeah, not just the commercial fishermen. You have all these recreational people and the recreational money that's spent in that state.
We're in battle. We need the right weapons to fight this problem.
Good luck and thank you for watching.